This is the notes for 8.3 if you use an 84 calculator. And this is really just demonstrating these problems. You can totally solve these on your own if you want to try them without a demonstration. But these are the solutions. So the two things you should know about the accumulation function and definite integrals, if in applied context you are given a rate function, the definite integral will give you the net change in the amount over that time period, so the difference between your starting amount and your ending amount. If you want to write a function so that you can answer questions like what is the maximum or is the function increasing or decreasing, then you can use the accumulation function that we learned about in chapter 6 to write that function. You do the accumulation function from some time period to x, and then you add on the initial amount that you have at that time period. I'll show you how to do this. All right, so the first question says, the rate at which people enter an auditorium for a rock concert is modeled by the function r, given by r of t. For the interval from 0 to 2 hours. R of t is measured in people per hour. No one is in the auditorium at t equals 0. I'm going to go ahead and write that down in function notation. The amount at 0 is 0. If I need it, I'll use that here. The doors close and the concert begins at time t equals 2. Okay, when you have a calculator and you're answering one of these questions about a function, I recommend the first thing you do is you grab your calculator and you define that function by graphing it. We also have a window that they gave us from 0 to 2. So I'm going to go ahead and grab my calculator, and this is my calculator, and I typed the function in already. When I hit the graph button, it looks like the graph is kind of off the screen, and I know that the window is from 0 to 2, so I'm going to hit the window button, and I'm going to change my x min to 0 and my x max to 2, and I'm going to change my y max because I'm noticing that that's off the screen. I don't know what the right answer is, but I'm just going to try 500 and see if that works. And then when I graph it, it just still goes off the screen. So I can quickly and easily make that y max even bigger. It's not a problem to change it. So you can start by guessing. If it doesn't work, guess again. So there's the function that we're looking at for this problem. The first question says, how many people are in the auditorium when the concert begins? The math we're going to do and what you should write down for part A is you should write the integral from 0 to 2 of r of t dt. We're looking for the net change in amount, and we have a rate function, and we just care how many are in the auditorium when the concert begins. So we should think about that initial value, but it was 0 for this case, so we don't need to worry about it for this one. Okay, the way we're going to do that on our calculator is first we're going to quit out of our graphing window by hitting second quit, and then we're going to hit math. And you can see the ninth one down says fn int. So I'm going to choose that option. I'm going to go 0 to 2. And then inside the parentheses, I would like to get my, my function. And the way I do that is I hit vars, yvars, function, and then it's the very first one is where we typed that equation. And then we do have to tell it that it's an x. It's a function, so we put y of x in there, and then we hit x, and then we have our integral looking really lovely. Our answer is 980. That is not a rounding value. That is the actual value of the integral. So that means that there are 900 and, did I say 87? 980, I forgot the number. 980 people in the auditorium when the concert begins. Okay, part B, find the time when the rate at which people enter the auditorium is a maximum. The way you find a maximum for a function is you take the derivative and you find the critical points. So we're going to take that derivative, r prime of t, you have to take the derivative by hand. You have to show that step, although you don't have to do things like multiply 2 times 1380. Your calculator is totally capable of doing that for you. So you don't have to do that multiplication. You can if you want to, but it would save time not to. And then if you're looking for a maximum, you want to look for where that critical point happens, and you want to find the critical point. You also should think about the endpoints. In this particular situation, your derivative is a quadratic, so it should be pretty easy to justify why you don't have to worry about the endpoints. So on my grapher, I'm going to go back to my y equals window. I don't want this graph to show up because that's confusing, so I'm going to undo that highlighting, and then I'm going to type my other graph in. So 1380 times 2. I'm making a video, Isla. And that's my derivative equation. Notice I didn't have to do the math because it will do that for me. And there's the derivative. I notice that the derivative starts off at 0 and then starts increasing. So that endpoint is definitely not a max. And then the derivative is positive to negative at this point. I'm going to hit the second calc button so I can figure out what that value is. Choose 0. It says left bound, and you can either get to the left bound by arrowing around to it, or you could type a number and hit enter, and it'll put you on that right bound of 1. I can do the same thing by typing a 2, and that will put me at the left bound. It tells me to guess. You don't really need to guess. You can just hit enter one more time, and it'll tell you what your 0 is. So the time is 1.363. It says to justify the answer. I believe enough justification would be to say there is a max at t equals 1.363 seconds, no, hours, because r prime changes from positive to negative. All right. Part C says the total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function W models the total wait time for all the people who enter the auditorium before time t. The derivative of W is given by W prime of t, blah, blah, blah. Find W of 2 minus W of 1, the total wait time for those who enter the auditorium after t equals 1. Well, we know that the integral from 1 to 2, despite all those words, of W prime of t dt, no matter what it represents, is going to be W2 minus W1 because of the second part of the fundamental theorem of calculus. So we can grab our calculator and do that integral. We already have stuff saved on our calculator, so we can do the math 9 again. And we want to this time go from 1 to 2 because they told us to. And then we're going to do our vars, y vars function. We're doing y1 again. We now have another function, but we don't want the derivative. And then we want to multiply that times 2 minus x, because that's what they gave us in this problem as the definition of W prime. And I typed it in wrong because I put a 2 instead of an x. I don't know if you see that. So I'm going to go ahead and fix that. And I got 387.5 when I typed it in correctly. And when I first did this problem, I thought 387.5 hours? That's a long time to wait for a concert. But then I realized that it was the time that all of the people were waiting, not just the time that one person was waiting. It wasn't actually all of the people at the whole concert. It was only those who entered an hour after the doors opened up. So part D says, on average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open. So that's going to be T equals 0. And use the model for total wait time from part C. So we're going to do the same idea that we did from part C, but this time we're going to go from 0 to 2. And that would give us the total wait time for everybody. And then we're going to divide that answer by 980 people so that we can get the wait time per person. And that would give us hours per person. I want to really point out that it's so tempting to do the average value of the W prime function, but that doesn't tell us the wait time per person. It would tell us the wait time per hour, and that is kind of a meaningless measurement. So we're going to go ahead and type that onto our calculator. So this time, when we do our integral, we're going to go from 0 to 2. And I'm just really glad that I saved that function because I have had to type it so many times and I didn't have to retype it ever. So that's kind of nice. And then this is the total wait time for everybody. And I'm going to divide that by 980 people from part A. And that means that each person is waiting 0.776 hours. And that makes a little more sense because that would be about 45 minutes, which just seems like a reasonable amount of time to wait for a concert to start. All right, that's how to use your 84 to solve this particular problem with a rate function in it. Thank you.